We're going to have a look at valence shell electron pair repulsion theory, also known as VSEPR theory. This basically is molecular geometry, so shapes of molecules. For that, we need to look at the fact that electrons take up space, electrons repel each other, and a molecule is going to orient itself in 3 dimensions to minimize those electron-electron repulsions. So using this PhET simulator, we're going to go and we're going to select model, and we're going to use our flowchart. Okay, we're going to build the models. We're going to say, is there a central atom present? No, there's not. So this is what we're going to call linear diatomic. It's a straight line between the 2 atoms. I'm going to turn on those names at the bottom so I can see the name of the molecular geometry. When I'm done, remove all my substituents by hitting the remove button, start again. So on the central atom, I'm going to put 2 substituents. Is there a central atom present? Yes, there is. Are there 3 or more substituents? No, there's not. So I'm going to move across in my flowchart here, and what I'm going to find is because there's no lone pairs on the central atom, it's essentially 180 degrees, so I call that linear triatomic. All right. If I create a central atom with 2 substituents, but there are lone pairs, I'm going to find that the lone pairs cause the geometry to move from 2D to 3D. I call this shape bent. All right, so you can drag the model around on the screen. You can see that it is in fact 3 dimensions, and it's when I added those lone pairs that the bonding pairs moved away from each other. If I make a central atom where there's 3 substituents and no lone pairs, it's a flat molecule. The bond angles are 120 degrees, right? But as soon as I put a lone pair of electrons on that central atom, those bonds tighten up from 120 to 109 degrees, and I call this shape trigonopyramidal. If I replace that lone pair with an atom, the fourth substituent is now an atom. I call that shape tetrahedral, right? Because the substituent atoms occupy the vertices of the tetrahedron polygon. All right, here's the molecular geometry flowchart. In order to use it, you need a correct Lewis structure to start. So again, that's why being able to draw Lewis structures is so important. In our next video, we'll look at bond and then molecular polarity.